Okay, hello everyone. My name is Nina Schubak, and I'm going to talk about SCORE Working Group 156. The title of our working group is Establishing Active Fluorescence as a Primary Productivity Metric for the World's Coasts and Oceans. First of all, a tiny bit of background. So, active fluorometers are these instruments which one can use to very precisely induce and measure chlorophyll A fluorescence. And that information then can be used in somewhat enigmatic ways to infer information about phytoplankton primary productivity. And of course, we are all really interested in measuring and monitoring primary productivity in the oceans. So having an instrument where you just have to press a button and you get a metric of primary productivity would be awfully handy. However, really surprisingly, it's not quite as easy as just pressing a button. And at the moment, there's quite a lot of confusion in the user community on how to best deploy these instruments. And then obviously they don't actually measure primary productivity directly, but you have to use biophysical models to estimate rates of electron transport and then convert these into rates of carbon fixation. And there's a few slightly different ways out there at the moment. And to the end user, it's very confusing to decide which one to use. And there's also quite a lot of confusion about nomenclature, where really every research group uses different abbreviations for the same parameters. And for a new user of these techniques, this can just be awfully confusing, which is a real shame because since the introduction of these instruments to oceanography, a hell of a lot of progress has been made. And the confusion kind of masks this progress. So, for example, the instruments we have available now are a lot more sensitive and sophisticated than what we used to have. And a lot of progress has been made in terms of how to interpret this active fluorescence data in terms of productivity, but also in terms of understanding how the environment controls productivity, and also to infer information about taxonomic composition of phytoplankton in the ocean. And what I personally think is really, really cool is that these instruments are now really at a point where we can deploy them on moorings and floats and gliders, and they can autonomously acquire data, and we can start accumulating these really big global data sets of active fluorescence. So our working group chairs are Philippe Tortel and Dave Saget, and then we've got a very long list of members and associate members. And what's maybe important to point out here is that our members are not just users of active fluorometers, but also engineers and manufacturers. So we all came together to address some of this question. Our objectives were, well, first of all, to ensure intercomparability of different instruments which are currently on the market, because if we want to accumulate global data sets, it would be really nice if the data collected with different instruments would remain comparable. Then we want to provide some consensus best practice recommendations to the user. We want to develop and provide some open source software where end users can reanalyze the active fluorescence data using different algorithms to calculate electron transport and productivity and compare these different approaches to each other in an easy way. We want to develop a global database structure where this comparable data can be deposited and reanalyzed as really, really big data sets. And we want to build a framework of how to do this. So how to use these large, globally consistent data sets of active fluorescence, in particular for the validation and refinement of ecosystem models and remote sensing algorithms. Our working group exists since 2019, and we started off with a big long meeting in Vancouver in June 2019, where we all came together and everybody brought their instruments, and we did a big laboratory intercomparison, which was a lot of fun. We also spent a lot of time just sitting together and identifying the problems that still are existent in the field and see where we can reach consensus and where really the disagreements between different groups lie. We initiated and discussed the format of a standard best practice document, which we want to create and make available to the users. And we discussed the development of this open source software for the user and also options for a global database. Then, not that long after, I had a second in-person meeting in February 2020 at the Ocean Science meeting in San Diego, where mainly we finalized the structure of our standard best practice document and identified lead authors for the different sections. We also spent a lot of time discussing on how and where to create a global database, and we gave a tutorial presentation at the Ocean Science meeting. Since the establishment of our working group, different working group members have published quite a lot of articles related to our work. And one I should maybe point out here is by Ryan, Cook, and Robinson, which should really be out in the next couple of weeks, which is the first initiation of this data processing hub, which we will continue to extend and refine. We are all working on the document of standard best practices, and we hope that a first version will be available for community review in 2021. In parallel to this very long standard best practice document, we are writing a review article which touches on all these aspects, which we will discuss in the standard operating procedure document, and that will be submitted to Frontiers, hopefully by the end of this year. Since the meeting in San Diego, obviously we didn't have any in-person meetings, which is a crying shame, but we had very regular Zoom meetings to keep the momentum up, especially on our standard best practice document. We collected, while we were still able to collect field data, quite a lot of field data, and we are all busy analyzing this and discussing with each other on how to best do this. We had a lot of field campaigns planned where we would use our best practice recommendations and test our best practice recommendations. Obviously, now we don't really know how many of these will actually happen, but we are pursuing them anyway. We were developing training workshops, in particular in South and Central America, and these are still being developed, and we hope we can do some of them next year, but obviously we don't really know. And we also tried to come up with some COVID contingency plans. So there was quite a lot of intercomparison lab work we still wanted to do. So instead of all coming together in one lab, we are now trying to work out how we can do some sort of global workshop where we distribute different aspects of lab work across different institutions and all work in our own laboratory, but come up with some comparable results.